gentlemen, welcome. It is 4 p.m., so that means it's time for another lecture and presentation. And this time we'll be asking ourselves when a robot is smart enough. So please give a warm welcome to your speaker, Tomáš Jukin.
Do you hear me? Yeah, perfect. Just before we start, the talk used to be in Czech in original, but because maybe we have many guys and girls speaking English only. Yeah, is here at least somebody who is speaking only English, please? Could you? Yeah, perfect. So it makes sense to have it in English, if it's okay with you, yeah? For me, my English is far from being perfect, but I will try my best, I promise. When a robot has all features which are required for him to fulfill its purpose, its main goal, that is the very moment when we call that, or when we are able to say that the robot is smart enough. Yeah? And today I'm going to show you how we can achieve this, how you can build your very own smart enough robot at home. My name is Tomáš Jukin. You can find me on Twitter with that @Inza handle. In my normal life, I am a big fan of IoT, of artificial intelligence, and of robotics. And in my working time, I am a proud CTO and co-owner of a company called Juicimo, where I am something what we in Czech call hlavní divočák for iOS, Swift, and Ruby, yeah? For the English guys, like you can ask the others after the speech about the translation, yeah? It's funny. The most important thing is that whatever I see, whatever I show, you can find on GitHub, yeah? It's completely open source, and I am in fact doing kind of like friendly advising, whatever. I am really curious if you will try it by yourself. Definitely let me know on my Twitter, or you can even spam our company Twitter. And we can either provide advice or you can report things. And mainly I will share my slides after the talk there, yeah, the link to find them. I am today in front of you not alone, in fact. I have a little guy here, yeah, this little fancy thingy, which is called Probie Robot. Looks like this, and this, what you see on the slide, is a 2.0 version of it. And just in purpose of this talk, I have made a complete refactoring, which means rebuilding it to this 3.0 version, which I'm going to talk about today. It has some nice pictures, yeah, because it's quite a small compared to for the like guys in the end of the audience. So I have some big pictures as well. Yeah, and it's like fancy device, yeah. You can see the hot glue, yeah, and the wooden sticks. That's the main component of it. It in fact had quite a decent evolution. Yeah, we have even special hashtag for that event. This is the very first version, yeah. The hero cam is the best thing, and lot of tape. There was this previous version, 2.0, and today we have another version, 3.0. Every version had its own event, which was related, where we either built it or improved it, yeah? There are the violet things, which are the tags of version of source code in GitHub, yeah, for the current version. Nobody knows what will happen in future, even me, yeah, so we will see. And as I've promised, I would like to share with you how the heck this thing functions, how I can build my very own Probie. But before we will dive into that direction, I definitely have to give you a super short Robotics 101, yeah? First of all, there is a huge difference regarding the MCU, aka Master Control Unit, yeah? We have two types of such devices. That's basically the brain, or basically the thing which kind of controls the device. We can have either microcomputer or microcontroller. What the heck is the difference, yeah? Microcomputer, example of such is Raspberry Pi, yeah? It's computer just micro, really, really small. compared to, that's microcomputer. Compared to microcontroller, such as Arduino, these devices, by the way, look like this, yeah? So maybe you have heard already one of the names. The important thing is that the microcontroller is too dumb to being a computer, but still is programmable, and we call it microcontroller. Yeah, in fact, the microcontroller device does not fulfill the von Neumann architecture of computers, yeah, which is the reason why it cannot be computer. Those devices have one big limitation for us, which is they are like not so much powerful, yeah, especially in the area of Arduino, yeah, it's really funny, yeah, you are accustomed to have gigabytes of RAM, and this little guy has 2 kilobytes of RAM, kilobytes, yeah, and it has only 32 kilobytes of a memory to your program, where 4 of them is eaten by bootloader, yeah, so you have just 28 kilobytes for your program, yeah, and that means, sadly, one thing, yeah, and that thing is C, yeah, as you will see in a moment, yeah, wow, I could tweet that, yeah, it is a C, as you will see in a moment. Okay, another part of necessary thingy related to robotics is how the heck I can connect or interconnect those devices, how they are able to communicate. So this is a super simple overview of ways of wired communications, yeah? Inside the guy, inside the robot, you will have just wires everywhere, yeah, as you can see later. First of the options which we have is called inter-circuit, like protocol / way of wired communication, and it's very often misused. It's really popular in this area of Internet of Things / open hardware, and it actually has been invented in order to allow 2 devices on the same like board, yeah, to communicate. But these open hardware guys are suddenly using it, and not just them. You know Lego Mindstorms, for instance? Yeah, those awesome Lego robots, really expensive, yeah, and not so powerful, but nice drag and drop interface, right? So they have like this, the cables, yeah, they have the Area 45 connectors, or Area 11 or something. And guess what is in those wires like this? There is basically I2C, yeah? So they completely like misuse that. And if Lego can do it, we can do it too, yeah? And that is the reason why the previous version of Probie actually used this type of communication. Then we have SPI, yeah? Just notice, please, those fancy animals here, yeah? The I2C is little like snail, yeah? He is like relatively easy to use, but can be better, yeah? So we have a turtle, yeah? And SPI is another type of communication. I'm not going to dive into all of those because that would consume the whole talk, yeah? And I have plenty of more things to uncover and share. So we will be a little bit faster, but that's another type. And what is better than a turtle? Yeah, it is a rabbit. Yeah, and this is very popular. It's called UART. Yeah, really thoughtful explanation, in fact. Yeah, and this you will very often hear in the area of Arduino's Raspberry Pi. Yeah, there is even a reason why I will show in a moment. And I'm using it in this version of Probie, in fact. And big question is, what is better than a rabbit? It is the RS-232, aka comport, yeah, cheetah. By the way, this comport, especially those who are a little bit older than me or not the youngest guys here, know very well, because do you remember those old mices with this 9-pin connector, yeah, before USB era? That's the comport, my friends. And now, this guy, this UART, is actually a little bit messed up version of this awesome friend, yeah? This guy has 9 wires, which is basically like the voltage, the ground, and 2 RxTX, yeah, receive and transmit wires, and then some interrupts. And then some supposedly clever guy came and said, 9 wires, too much. Let's be more cheap, yeah? In order that in the East factories, they can produce more of those devices, yeah, even cheaper. So let's strip it off. Who wants to use interrupts, yeah? So sad story, by the way. And that's how the UART was born, yeah? Like there is a lot of interesting things here, but we have to move on a little bit. And now, The best thing ever. What is better than a cheetah? My friends, I'm glad to announce that better than cheetah is a tank. AKA RS-485, which is the industrial upgrade of the RS-232, basically, yeah? This is something you would love to have. Unfortunately, no support of it, yeah? By default, these two devices do support these three types of communications. There are ways, hardware extensions, core shield, or etc., shields, etc., which will allow you to use even those, but not by default. Which is why I would like to be so much friendly as is possible for you. So that's why I will try to use those things, yeah, here and in the Probie for the ease of you to build your very own. So let's take a look on the hardware itself. What does a 4 wheels self-driving robotic car consists of? Yeah. So that's interesting. Basically, first thing you need is a brain. Yeah. And as any other human being, second is the hearth, yeah, or whatever is that. I cannot pronounce that, yeah, correctly. I know it. So basically, what we would like to achieve, we would like to build a mighty robot like this one. Definitely, we will need a brain, and we will need this heart thingy. Perfect. So what it will be, it's obvious. Raspberry Pi and Arduino Uno, yeah? Then we would like to see some stuff from the Raspberry Pi without that ugly HDMI cable. Let's have a TFT touchscreen. Then we can communicate between these two devices over the I2C bus. They have different voltage, so we need some little abomination guy here, which will be the level converter. Boring stuff. Then we will obviously need some legs, aka wheels with motor. Then we need a motor controller, aka motor driver. We would like to have some Wi-Fi because our poor thing is a Raspberry Pi 1, so we need special dongle for it. Then the robot needs to see something. Let's add ultrasonic sensor on a servo so he can rotate it. We need more ultrasonic sensors, even more ultrasonic sensors. And then would be nice to have a peer sensor so he can detect when somebody will move itself nearby. This actually I removed in the latest version because I did, in fact, before my talk, like 1 month before, full refactoring. Disassemble to the last piece, reassemble, reprogram, redone, and I didn't manage to add that yet, yeah? So it's a nice thing, but not yet there in the last version. And then this is RTC module to have a time even when you unplug the device. This one is really shitty from China. Don't buy that. Yeah, buy another one. And then obviously you need some batteries. Yeah, without batteries there is no fun. I have been glad enough for you that there is a list of things, yeah, and where to buy in AliExpress. Very cheap. The most important tool you will need is not a solder machine or soldering machine, but those little guys, yeah? Because it's sometimes tricky to fit the wires with such like not effective thing as are your fingers, yeah? So those I can recommend, just not even $1, very nice. AliExpress again. Then, there is some idea behind the whole thing, aka how those awesome components should be assembled, yeah? Once again, brain and heart, Raspberry Pi and Arduino Uno, these two have to communicate. How? Let's use this little guy here and this little guy here and connect them via USB wire. That's how the latest version of Probie functions. And let's use this UART thing over the USB cable. That's something both devices do support natively. You need a little bit persuasion on the Raspberry Pi side, but it works. Or you can do as my previous version of Probie did, which is the I2C bus. You need this level shifter. Why? This guy is 3.3 volts. That guy is 5 volts. Important question. What will happen if you will connect 3.3 volts and you will put there 5 volts? The 3.3 volts device will say bye-bye and dies. Yeah? So don't do that. You have been warned. We have stick with the USB way. Then we have a motor driver and something which is called PWM on those Arduino pins. That's a shortcut for pulse width modulation. You can Google it later. We have no time to explain. But in the speakers corners, I am happy to explain. Yeah? And the important thing is that this guy will control the motors up to with 12 volts. Nice. What next? Obviously, we need a Wi-Fi, right? Once again. And USB is a big friend. We have 4 USB ports, so still we are able to manage it. We have the awesome TFT display connected using the SPI. And we have a servo. On a servo, we have the ultrasonic sensor. I like ultrasonic sensors. Yeah. There is a purpose for it. Yeah. The front one, the back one, blah, blah, blah. Then we can have this RTC module. Yeah. The different one, not this one. That's a crap. The peer sensor. Both are connected using the I2C bus into the Arduino. Yeah. Let's add ultrasonic sensors. And then I had an issue with the previous version of Probie. Yeah? I went out of the 3 pins of the Arduino Uno at this moment. So I had to add the secondary Arduino device, which is called Arduino Micro, and connect those 2 using I2C bus. And then I am happy because I have my other ultrasonic sensors. Yeah? And then I have decided that when I disassembled and I had to reassemble, oh my God, let's see, 3 devices kill me. Yeah? So I said no. And I bought Arduino Mega, which is a bigger version. Same speed, same slow speed, but has more pins, yeah, more holes. Perfect. Nice, yeah? So this is how it will all communicate everything, yeah? One with each other. And now, the important question of power. How we will power those bests, yeah? So we have the microcomputer, the microcontroller, and this friendly guy, the motor driver. Perfect. We have a communication here that's happening over the USB. Both devices on the USB side are 5 volts. Perfect, solved, done, next. If we would be using the I2C bus, we need to have this little guy to correctly shift the voltage. Let's forget that and stick with the USB. Perfect. So what we need else? We need to power this computer by 5 volts somehow. And we need to power the Arduino Mega. We have a freedom to choose between 6 or I think 12 or up to 15 volts. Using this little black guy, you will put that round, plug. Okay, and then we have the motor driver. He can consume similar thing, between 6 or up to 12 or even 15 volts, I think. Okay, so there were some batteries provided from China. They look like this, yeah? And it's not AA battery, it's a special form, yeah? And those from China, they didn't look like this. They are not so cute. And they don't have the capacity, which is the main problem. So I thrown them away and bought like same dimension, but some normal, it's like Lion accumulator. They have both 3.5 volts, and together they make 7 volts, which is the thing I need. I'm 100% happy. And then with the Raspberry Pi, was a tricky situation. Yes, you can find out some device which will convert the voltage from this to this 5 volts, because when you put everything else except 5 volts into Raspberry Pi, like through like the USB thingy, or the 5 volts power plug, it will die. Yeah? If you will put anything except this 3.3 volts, it will still die. So I have given up and bought a power bank, yeah? And easy solution. Not quite nice, but what can we do? So this is how the thing will be powered. Perfect. So let's take a look at the hearth of the device, aka how the Arduino fits in there, yeah? First question. How the heck we develop for this Arduino? By the way, is here anybody who was been using Arduino for whatever, some playing? Yeah, just, oh nice, nearly like quarter/third of you, perfect. We use a language which is called wiring/processing. What the heck is this crazy name? It's a dialect of C/C++. But our device is really, really slow. So let's forget about C++, please, yeah? Because we don't have either RAM or even the power. Like, it's possible, but your program suddenly has much less space, yeah, when you use C++. Okay, so sad. Whatever, we have a C, yeah? For Arduino, it's really easy to make the basic programs. We have just 2 functions. One is the setup. When you plug the power, it will be run once. And the loop is the second one, which will iterate endlessly, yeah? And bang, this is how you make code for Arduino, yeah? One endless loop, so sad. That reminds me that there are 5 circles of hell in the Arduino ecosystem. First is the ENO includes. ENO is an abomination shortcut of the Arduino files, yeah? And the normal C or C++ code has always these .h, like header files, and .c or .c+cpp files for code. And with those 2 things, I know that people used to Java, Dart, Ruby, whatever you like, they have just one type of files, yeah? It's this like invention of C ecosystem guys to have 2 types, but they can be quite powerful, yeah? You are the master there, yeah? Not in the ENO ecosystem, because you have just one ENO file. You cannot create another ENO file in your project, just one. And that means what? That means that you have to be a little bit piggy, like I was, and you have to type actual implementation into .h files, yeah? It's like that every C programmer is now killing himself. Hopefully we don't have so many C programmers here, yeah? Nobody has committed suicide yet? Nice. Then there are some libraries, yeah, like the one for LCD. It's one library and many LCDs you can buy, yeah? Every manufacturer in China is doing it differently. You need different libraries. You have to Google them. It's epic, yeah? You will spend hours on this. The things you buy from China are from China. No, sorry. I mean, they are cheap and they are cheap, yeah? They don't withstand much. So let's say that every second, let's say that out of 10 devices, 10 the same device, only 8 of them do function. Which is okay because they sell them in batches for 10, yeah? So it's okay. Then there is something which was completely new, sorry, for me. And that is that there is such thing like a hardware bug, yeah? You actually are debugging the thing. It's not doing what you wanted. And you, for 1 hour, are changing the things in code. And then you will realize that the wire was just went out, yeah? And you had to plug it back. So that was a new thing for me, yeah? Before I happened to be this kind of hardware developer. And then Probie before didn't have a switch on off, yeah? Like for a programmer, I didn't thought it's needed, yeah? It is needed. So now it has it. Yeah, actually, there has been multiple versions of the firmware. Yeah, the software for this Arduino thing is often called firmware. You can find many of those on my GitHub here. Basically, this one and this one, they didn't live, yeah, the source code. It was too ugly to get it, yeah? So, yeah, the rest is there. You can find, there are even the tags here. It's perfect. Yeah, here is just like an example of how some kind of way how I tried to put some structure, because as I said, my background is Ruby and the Swift, yeah? So the C I know, and I always, it's non-object, yeah, it's the C, not even C++. So I at least try to have a good structure with those imports, etc., yeah? We don't have many time, so I cannot dive here so much as I wanted. So it will be a little bit slideshow, but you can find all the things later in the presentation. Then I was kind enough to even provide how you will connect the things with a link to the tutorial. It's perfect, yeah? There is some related code. Yeah, like in the end, it's simple, relatively. You just say, hey, on this pin, make it on or off, yeah, and stuff like that. And that's basically the main thingy. Same for the how to connect to devices with the I2C bus, yeah? Basic important thing, it's like one way only. Eh? You have one tutorial for the way from here to here, and second tutorial for the opposite direction. When you have the UART over USB, it's much better. I can recommend. Yeah. Then, as a programmer, you always need a good structure, even inside a device which has 2 kilobytes of RAM. Yeah. So let's do it. We have a hardware. That's the physical things, wires, devices. Then you have something which is called hardware abstraction layer. You should, is the same thing. You should never have your SQL queries spread it everywhere in your code in a web app, right? like many PHP programmers does it, yeah? So don't do that, and in the same way, don't touch the hardware on any place in your code, yeah? Don't touch it everywhere. Put a hardware abstraction layer and call those functions from there. Yeah, because suddenly it will be much easier to replace the I2C bus for a UART, for instance, etc. Then, the device on the Arduino side is driven by the finite state machine, yeah? That's a friend. And that is an awesome thing because, dear attendees, the Arduino doesn't have any kind of multitasking. No multi-cores, nothing, yeah? One cycle going in like continuous loop, yeah? Infinite one, till there is the power. So you have to somehow manage your very own multitasking solution, yeah? Which is something I did. I put there some kind of simulated preemptive multitasking. Yeah, it's not fully preemptive multitasking, but a simulation of it, but somehow it works, yeah? It's like a little bit standard in there, because it doesn't make sense to implement full-fledged preemptive multitasking. That would consume too much of the resources of the device, yeah? So when you need something better than Arduino, where it's like scheduling, for instance, you need to visit the Big Clown stand there, right? They have a better device. So, it's just an example. There is some configuration, obviously, and the finite state machine, it's like trivial, looks like this, yeah? The state diagrams, many arrows. A big question, have anybody of you used a finite state machine before in any kind of context? Yeah, some of you, okay, a lot of you, perfect, yeah? I will not explain in detail, I don't have even a time for it, but I have some events, which, for instance, the ultrasonic sensor is producing an event when there is an obstacle nearby, and the state machine will change its state, yeah? When I put the event names there, it's a little bit, it's suddenly more, you know, spread. And how it works in code, in fact, it's a relatively simple thingy. This is the detection of a collision type, yeah, based on some distance. Example, this is a little bit small letters, but this is a thing which triggers the events to the finite state machines. And what the heck? Yeah, and this is, by the way, events based on the collision types. Yeah, like I'm triggering on 2 places in code, like there. Yeah, like it's just a shortcut that in the end it's just like if and methods or functions, in fact. So it's not something like magical here, right? I have 12 more minutes and not even in half. So, but I will manage, right? There is just so much to say. So let's now discuss a little bit this brain thingy, yeah? This Raspberry Pi parts, yeah? Because now I have more or less described, at least tried, the Arduino part. And now regarding the Raspberry Pi, because the core idea is that the Arduino will control the basic things, and the Raspberry Pi is controlling the intelligence, yeah? That higher brain functions, hopefully. So artificial intelligence 101, before we dive in. How to make an AI in such device. You basically have multiple options. We have choose this MAS. I have even explanation here. Yeah, scripting means I will just make some spaghetti, yeah, and done. No thinking. Lot of if conditions will do it, right? So let's do it. Or there is a such thing like hierarchical task networks. There is a link in the end. It's like too complex to explain, but really interesting thing. These state machines, finite state machines, they are awesome. That's the thing I have shown before. And basically what is a nice, decent trick is that you can make a hierarchy out of them. Because what is the issue of hierarchical of the normal finite state machines is that when there is a lot of states, that guy goes exponentially, yeah? That amount of states and transitions goes like crazy, yeah? And then in a moment, nobody can understand it, even not you, yeah? I tried, trust me. So then you should introduce these hierarchical state machines. That example of such thing could be that in Doom, the character is either walking, which is controlled by one state machine, and the shooting or the type of gun is controlled by another one, and they have some kind of relation between them. Yeah, perfect. So, okay, but somebody can say, too much work. Where is the fun in it? And that's where this part, yeah, is here. Or we can say no to all these stuff. And we can go the heuristic, the path of heuristics. Yeah, that basically means mainly that, okay, let's forget about the perfect solution. Too difficult to find. No. I will just find and use some solution which is good enough for me. And I can do that in a polynomial time, yeah, instead of this like full-fledged thingies, yeah. So this is something I quite like. You have multiple ways what to use the multi-agent system, which is the one I love, genetic algorithms or genetic programmings, or artificial neural nets, yeah, many things here. Perfect. Or you can be crazy and connect all those things together, yeah. There is a one piece missing here, yeah. And I will show which one it is, yeah, in a moment. Yeah, here is in fact some example of a state machine. We have seen something, yeah. We can have like different state machines for different parts of the robot, but how to combine those things? Yeah, as I have said, the exponential thing little bit kills the party here, yeah. And that's when or where the behavior trees came in, yeah. I have even nice little drawing here, yeah, and just 9 minutes. This is basically a way how you can combine multiple AI techniques together, yeah. I don't have much time to explain, so I will just try to motivate you here a little bit. And there is a link in the end of presentation, yeah. Basically, it is a thing which is processed. It's a tree, right? So it's processed from top, from the root, and there is basically always a condition that either you are going to dive in or to do such thing, or if that thing is not applicable, you will just try next one, yeah? And you have either the sequence or selection, so you have some kind of similar things like you have in normal programming, and it is a really awesome things, yeah? Even Unreal has it, yeah? Not just the Arduino, so really useful. Yeah, here are some links about the explanation. I have discussed very shortly many topics, so you have always the links here, yeah? It's good thing, yeah? It's really awesome and interesting area, those AI like problems and processes and all this. So now let's take a look what I have choose for the Probie. I have, tinkered with the brain, how we develop for Raspberry Pi. I don't know what you are doing, but I am doing it in Ruby, yeah? Which is nice, yeah? On Raspberry Pi, you can, it's not just limited, please, to the Ruby, yeah? You can do whatever you like. Just avoid Java, yeah? Because Raspberry Pi is still like too slow for Java. But Dart might be awesome option, right? It has the precise garbage collector, so perfect. Yeah, on Raspberry Pi you can do whatever you like. It's a full-featured Linux running on a ARM processor. Yeah, so many things, especially for the C word, will not work. Before we continue, once again, 5 circles of hell, this time on Raspberry Pi. It is USB-driven computer. Raspberry Pi is awesome device for $35. That is the main thing. Raspberry Pi Foundation says whatever we do costs $35, and everything else is like not so important like this, yeah? Because they would like to spread this computer infection everywhere, yeah? And that means compromises. So between a network card and the CPU or system on a chip is what? USB bus in the device, yeah? That's something you usually have between your computer and a printer, right? So little bit unstable. When you try to use many features at once on the Raspberry Pi, which is in theory capable, in practice it's not, yeah? It will go mad. There is no Wi-Fi on the previous ones. That's pretty much solved with the version 3, and it's unstable. There is no person in the world who is running Raspberry Pi in a full saturation for more than 1 week. Yeah, and by a full saturation, I don't mean let's send a temperature once per hour, right? I mean compute things in the robot, yeah? So it's okay, I'm not saying it's bad, it's good, it's awesome. It just has its own limitation, and it's hobby usage. So what I have done for this brain, and 5 minutes till the end. So I built, or that's something which is not like completed yet, yeah, but I'm quite in progress there. I am building a multi-agent system based on actor concurrent programming and in Ruby, yeah, and source code is there. The structure of hardware or software or the brain is that there is the Raspbian, yeah, it's a fork of Debian, the Linux-based operating system of Raspberry Pi. There is a Ruby version manager. Then there is a Ruby. Then there is an actor-oriented programming library and my very own RubyGem and the program for the Probie, yeah, everything on GitHub. And how this Probie MAS thingy like functions. There is some Ruby object-oriented programming, obviously, and then some things from the actor-oriented programming thing. By the way, is here anybody who knows actor-oriented programming? One, two, well, yeah, some of you, perfect. It's a nice thing you should explore, even without Raspberry Pi, yeah? Just to know, it's interesting. It's like objects, but actor is an object which has basically its very own thread, yeah, and lives there. And it solves messaging in a non-blocking way. Very nice technology. And not just limited to Ruby, right? And then we have some kind of agent, and finally the movement agent. Yeah, basically, I just separated, which is the core idea of those MAS, multi-agent systems, that I separated the functionality between multiple different small pieces of program, and nowhere is written the big picture. Instead, this final desired behavior kind of emerges automatically, yeah, because there is a phenomenon called emergence, like bounded with those multi-agent systems, yeah. It's something like related to the fact that even people like have some behavior when you have a lot of them, like you, have some kind of behavior which single one of you don't even know about, yeah. So this phenomenon is what those multi-agent systems are based on, yeah? So I have a bunch of agents which are somehow like communicating, but the main thing is that there is some kind of division of responsibility, yeah? That only this guy is talking to motors. Only those two guys get information from sensors. It's not this very often regarding those small devices, smaller than normal computer, smaller than your average Java EE app, yeah? It's this very strict division of responsibility even into like small components. And that basically the main thing, main advantage of the multi-agent systems is that simple agents, simple programs can suddenly together perform even complex tasks, yeah? Here are some Ruby examples, yeah? Like Ruby is awesome, but I have to a little bit move on. But we are coming to the end, hopefully. So like this is then some idea that it's really abstract, yeah? Ruby is awesome language, by the way, yeah? Can be a little bit cryptic, but it's pure. Yeah, it's like good Portuguese wine, yeah? So, it's red, yeah, as well. There is one more important technology I would like to share with you, aside the C, Ruby, and those nitty-gritties. And it's called ROS, yeah? Because with Ruby, C, Python, I don't know, you can achieve a lot of things, yeah? But it's all like a trial version, yeah? It's like all like to play with. But if you would like to have something real, that's where the ROS comes in, yeah? ROS is a shortcut from the robotic operating system or robot operating system. It's entire big open source project, like huge, yeah? And it's used by universities and contributed into and the research centers around the world. And there is one purpose, and that's the robotics, yeah? It solves many, many common things which pretty much every robot has to solve, yeah? And starting from the low-level features like communication, modulation, modularity, I mean everything. And then, if you do it in a great way, you have those awesome advantages. This screenshot is a part of that ROS, because it's a bunch of tools, basically. And it's called RVIS, like robotic visualization. And it is a software which allows you to see what the robot sensors see, yeah? It's perfect. You will spend ages configuring it, but when you do, it's awesome, yeah? This is some like final goal and should be a final goal in your robotic era exploration journey, yeah? So my recommendation is start with the Arduino, start slowly. then add Raspberry Pi, and then when you have awesome robot somehow working, let's go to this upper level and let's introduce this ROS operating system, yeah? It's a basically set of tools that means that you can still program in your very own favorite programming language, except PHP, yeah? Please leave that at home. So that's it. This would be last thing from me. Definitely, yeah. There is just a question slide, yeah. So here it is, yeah. Perfect. Questions. So if you have any kind of questions,
yes,
and
we
you have
actually.
many, right?
I can see that the comment section has become a real specimen of human intelligence. So let's see if we have some real questions that we can ask Tomáš. The first one, well, robots really don't suffer from this problem. The second one, what do you think about first Japanese sex smart robots?
What do you think about first smart robots? Like, is there any Arduino inside?
All right, second question. What is my purpose? Do you think that artificial intelligence can ask questions like this and can find answers to these questions if we can't?
Like, it depends, yes. Some of the artificial intelligence devices know a lot about the human behavior, yeah? Let's just ask Google, for instance. So, like, it depends, yeah? With the AI, it's like really difficult topic. And even such like questions, yeah, because there is no such thing like general AI, or there is, but every AI researcher will tell you that the general AI, that's what the human being hopefully has, is like the mecca for the AI researchers, yeah. Much easier are those really specialized AIs, one of them being the Google Assistant, for instance, right, which are able even today solve some like specific problems. But this generalization is a really tough topic. Yeah, there are a few companies who do research in this area, but there are no real published outcomes there. I hope it's the answer to the question, more or less.
All right, moving on to the next one.
Yeah, no, I am not sponsored by AliExpress, yeah. But I do like this thing that, you know, China did a free post, you know, little envelopes posting to the outside of the world. So that means that you will buy a Arduino for, I do not know, yeah, 300 korunas. And there is no, like post fee, yeah, if you buy just one at a time. So that means that if you buy 3, they still send, but in 3 envelopes. And there is no tracking, nothing, yeah. It will just arrive eventually in 2 months. Can I recommend? Is that answer? Okay.
We can move on to the next question.
Who will win, human or robots? Like, it depends. Have you seen Terminator? I am a fan of Skynet, yeah? In a way. Done, next. Yes, there actually even are such robots. There is a thing called MIT Robotics in the US, who is building questionable military-grade, like 4 legs robots. And that guy, in a sense, is aware of himself in the relation to the like place where he is, for instance. Yeah, so it very much depends what does it mean, a self-consciousness, yeah? Like if it's regarding to the space, like I mean the 3D space, right? So yes, he is, even today, yeah? And if you mean philosophy or something, I'm not sure, yeah? But there is, for instance, the IBM Newton, which in some areas might even be close to this one, yeah? But not like human is, yeah? Like, once again, very difficult and very generic questions, yeah? But hopefully I have answered. Do you think we can reach human-like robots? You mean in the body perspective, like humanoid? Or like, what the heck, it's like Cylons or what, yeah?
Can we get a clarification on this question, yeah?
Yeah. So in some way we actually not reached, but in some areas we even like left the humans already behind, yeah? Like take Google Images, yeah? like how the Google is able to provide you such, like in a such good results in a searching of your image database, which you never tagged, never did anything, right? There are deep neural nets behind that. And in that area, to recognize things on images, the computers are already far, far away, yeah? And the humans stayed here, yeah? Just saying some things.
I'm asking about in terms of learning, not in terms of like...
Because like, you know, the trick is that this neural net had to learn before it is able to give you the answers. So that's why I'm talking about that, yeah? So in that area of learning, it's already happening. But in the general learning, yeah, that young guy can eventually become a famous programmer or whatever, for instance, that is a question, yeah? Like not yet. Thanks God, yeah? Otherwise we would need to find another job, yeah? So, yeah, is that answer, hopefully? We have there is no question here, like I have not met him yet. Weapons. Asking for... Like, I hope not, like, please, yeah? Why not to use microcontroller only without MC? Like, I mean, in Arduino Uno, for instance, the microcontroller is the MCU, yeah? Like, without MCU, it would be just like wires, yeah? Or components. And what about ultrasonic sensor? Like how it functions? Actually, there's one thing I will share. Imagine, it is really fun fact, yeah? Because you will run into this wall at the moment one with your very first ultrasonic sensor. There is a such things I don't really like, it's called physics. That when I have my hand and it's an ultrasonic sensor beaming that direction, the majority of the surfaces of the real world behave like a mirror. That means the angle of trush is equal to angle of zoom. Yeah? And what that means for me, yeah? That means that when I am facing directly in a 90 degrees to the obstacle, I will actually measure this distance. But when I will not be 90 degrees, but like that, what I am going to measure is not this distance, but it's ping, pong, yeah? Is that distance, which would mean that my robot will very happily run into wall, yeah? And this is something you have to count with, basically. I hope it is an answer. Yeah? Can see a robot to do. Yes, I am not sure like if we have right place or space here, because this place here is too like small. And if I put it here, nobody sees, yeah? Just the flag. So I think that we can manage it somehow, yeah, like either in the speaker's corner or like, maybe I will a little bit do here, yeah? Let's try it. Yeah, let's hope he will not, he's slow in general, so yeah, first he will be like saying, hello, blah, 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 I am prepared for my lesson, and then, yeah. He like tries, but he has not the grip, right? Yeah.
Is he going to kill us?
No, he doesn't have any weapons, yeah? And I have actually never tested him on a, like, not flat surface. Yeah, in fact, it has ultrasonic sensors, right? So, and he is smart that if you will put this obstacle two, like, together, he will try to turn, yeah, already. So that's it, yeah?
Very good. I think this is a good place to end it, and I'm sure that Tomáš will be ready for your further questions about technology and maybe live demonstrations in the speaker's corner, which is here on the corridor. Thank you very much, and a round of big applause for Tomáš.
Thank you.